Hello everyone, it's November the 7th. Alright, let's do this. Maximum exclusive OR. For each query, you're given assorted nums of n non-negative integers and an integer maximum bit. You want to perform the following query n times. Find a non-negative integer k smaller than 2 to the maximum bits, such that nums 0 exclusive OR nums 1 exclusive for everything till nums so it's just exclusive for everything in nums, and then exclusive of k is maximized. Find a non-negative integer k such that exclusive for everybody and then exclusive for the k, the value is maximized. K is the answer to the ith query. Remove the last element. Okay, so a few things. When you say remove the last element, you just exclusive OR the last one, and then it will be done. Because if you exclusive OR the same one, it becomes 0. So that's how we can go through the query. And you perform n times, right? N query. So the first query is go all the way down. The second query, yeah, so every time you do it, you remove. Yeah, so I know exclusive OR of everybody at each query. So now you just need to find k, right? You have k, which is the a number which we can represent. But if you think about it, exclusive OR, when you have a 0, we should have a 1, right? We'll make it bigger. When you have a 1, you should have a 0. That's it, right? So in this case, we start with 0, 1, 1, and 1, 1. So exclusive of everybody, we got a 1, 1, which is 3. So now I have a limit of 1 left shift 2. So I have the smaller than that. Okay? So 1 left shift, so this is the maximum I can get. This is the maximum I can get. So when you have this, we just do it by itself, right? So that's k is the answer. Yeah, first one is 0. And next one, I exclusive OR this 1, 1. So that becomes 0. Because I exclusive 3 to it. And then we need to find, so we just do all ones. So that becomes 3. And next one, exclusive OR is 1. And then we just do 1, 0. Right? And then next one is 0. Yep, that's exactly what we're looking for. So how do I get a number? Maybe we can do 2's complement, right? So 1, 1 is, so it's 3. So minus 3 is going to be the 2's complement. And minus 2's complement minus 1, right? So 2's complement minus 1. Actually, I'm not sure how that one goes. So 2's complement minus 1. Or 2's complement plus 1. I forgot. How do you know I'm going to want to do 2's complement? Alright, 2's complement plus 1. You take the inverse. Oh, hold a second. You can do inverse. Wait, there is something called inverse. So 3. If I do inverse 3, what do I get? Look great. Well, if I do inverse 3, I got minus 4. What? Inverse 3 is minus 4? Ah, I see. So, okay. So what we want is inverse it, right? Because that's what we want, but we want a 0 and 0. I have to do inverse 3 and this whole thing and 2. Right? So basically, because when you inverse, it's represented by the signed integer, right? So it becomes 0, 0, and then with a bunch of 1s in the front. So if you want to get to this level, so you need to AND this with 1, 1, or it's 2, 1. Basically, we need to know. We need to know the number of bits. Right? That's what we need to know. The number of bits. How do we know the number of bits? How do we know the number of there is some way. How do we know the number of bits? Because I cannot go too much. It has to be, oh my god. I need to know what is the way? Find I don't need a number of bits. What I want is I don't know how to do that. Find a number. How do I say that? Binary number. I don't know how to express this. Wow, this is fine with all one. Does that make sense? I don't think that makes sense. That's not. It should be. If all one in a binary number that has the same number of bits. No. Yeah, they gotta be a way. Find the number of bits. Well, it's not a couple of bits, right? We can do a log. We just do how many times, right? Yeah, you log. Oh, there's a log plus 1. Okay, that's actually pretty easy. Binary to string. Okay, I guess we'll use log then. Okay, we'll use log. Yeah, I'm pretty sure there's a better way to do this. Right, I mean, anyway, what we want is get this. We will do its inverse, and we'll get the mask so we can get the answer. Okay. Oh, shoot. Oh, that's good. Good, good, good. Okay, so we got a total exclusive OR, and then from right to left, Alright, so we have exclusive OR, and then what we need is to say count. There'll be math log exclusive OR divide by math log 2. Alright, and then we'll integer this thing. And plus 1. I'm not sure. What if it's like 8? Yeah, what if it's 8? What if it's 8? A will be 3, right? Oh yeah, that's right. Because 1 0 0 0 is 8. Yeah, 1 0 0 is 4. 1 0 is okay. That makes sense. That makes sense. And then those will all become 3 plus 1 is 4. Okay. Yeah. Okay. That's fine. So we have the count, and math should be 1 left shift count minus 1, right? If you have if it's 2, then you 1 left shift 2, right? 1 2 1 left shift 2, yeah, and a minus 1, yes. So that's the math. And then what we do is we'll have int right, and then we'll say rest I. So you put the exclusive OR, we'll reverse it, actually I'm not sure, let's try this. We reverse it and then reverse it and math. An exclusive OR, or exclusive OR, none. Oh, but we have a maximum bit. Ooh, maximum bit. Okay, what if this, so this is the maximum possible, right? Oh, okay. Okay. That is the maximum possible. So what if my exclusive OR is really big? And if you think about it, if I have a small value, if I have a 0, and I have a maximum bit, I should use the maximum bit, right? But regardless, we have whatever the number that is. It could be even bigger, right? We have whatever the number is. And then, like this. And then its inverse is bigger. So whatever the value that can make it the maximum, right? Whatever can make it maximum. If that value is bigger than what I can provide, then you should just get the number of bits. Yes, you just get a number of bits. Yes, that's whatever it is, we do another mask. with a maximum mask. Because it cannot be bigger than that. Okay. Makes sense. So we have a max mask. We got a count, we got a mask, we do. So it's going to be so no, not this one, a max mask. So the first round is to get the one that we want, and then we do this to get what can actually be achieved, and then we'll return rest. Oopsie doodie. Okay, so we probably need to have, how about this? Nope. Ha. That is rich. Oh, hold on. Let's see. Well, we'll have. Let's see what's the exclusive or. Well. Binary. Okay. Oh. Yeah, that's true. 1-1. Exclusive. This one should be. Actually, I'm not sure what this one is. Yes, that's true. So, what is your mask? Okay, mask looks fine. Mask looks fine, and then this one and mask and max mask. How would I get 1? Right, if we do exclusive or and this, we shall get 0 and something. Yeah, 0. Right. If it's 0, which means, wait, hold on, we're a little bit confused. So we do exclusive or, so that's the final exclusive or value, right? So we need to find out what is the value that we need to do, right? We need to find out the value that we need to do. Oh, it is 0. Oh, I put it in the wrong order. Okay, so that's fine. That's nums.length minus 1. Right, so we get 0, and then we find the maximum we can get. And then the next one is 1. Next one is 1. That should be 0, right? I think the issue is happening in the count. So if exclusive all is 0, which it says will give you 1 bit. Well, technically it is 1 bit, right? But if it's 0, then it should be 0 bit. Well, mask should be 0. Wait a second. So exclusive was 0. Reverse is all 1s, right? And mask shouldn't you just use the max mask? Yeah, I feel like you should just use the max mask. Why you do it 2 times? Right, you do the reverse and well, because you don't want to include the previous one, so you want to know how many bits is actually valid. So you have bits, so those are valid, and you take them out, right? You take the valid bits out, because otherwise it's, yeah, okay, so you have the valid bits out. So if it's a 0, so there's no valid bits. So you take out nothing. Well, there's 1 valid bit, so you only do 1. That's not right. So you have the number of valid bits, right? Number of valid bits. So we got this one right, and next you have a 0, right? 0, we want to say we do a reverse, and we should AND the maximum bit. Oh, we do just AND the max max, right? Because the max is this. So you AND this, you take this out, which is the answer. In the first case, we have 0, 0, whatever, and then we do, yeah, all we need is a max. But what if the max is bigger, like here? And then we'll take yeah, I think that's exactly right. You don't have to do this. I think you just need to do this. It will work. There we go. Yeah. I don't know why you make things so much more complicated. And of course, we'll just call it mask. I don't understand. Why you make it so complicated? This is it. And in fact, we don't even have to do it first, right? We don't have to do it first. All we need, get exclusive all, get this, get mask. We'll start from 0. You know what? Let me redo it here. We'll call this mask, and then we'll redo the whole thing. I0 I nums.length I plus, right? Don't need this, don't need this. Res nums.length minus I go to this and this. Oh, we probably have to do this first. Get exclusive OR, and then we do the current, but it has to go to the end, right? I think this one should be right. Let's give it a shot. Sorry, I forgot the -1. Yep. Let's put all the other ones in. And another test. So after we get all the exclusive OR of nums, removing a number is equivalent to exclusive OR that number. No, I just go directly. We can prefix exclusive OR nums as we go, and each time, right? Each time, and the k and the k we find each time will be filled from right to left on the result array. Right? For the current prefix exclusive OR, right? The value that can make the k, the potential k, right? The potential k that can make it max, and make it max is the inverse of prefix OR. And since we have a cap on the size of k, we need to do this and mask, where mask is the largest number we can use. Yep, that's about it. Gonna run one more time. It will pass. I think this one takes a little bit longer than I will want. It's a fairly easy question, but I stumbled a little bit on how to get the largest. I was like going through a different way to get a mask, which really does not make any sense now on hindsight. I don't know why I thought about it that way. Bit masking, prefix. You don't need prefix, right? You can just go straight through. Oh, there's also do prefix. Remove last. Yeah, I don't know. This one doesn't look that optimized. You don't have to. You can just go straight forward. All right, that's about it. I'll see you guys tomorrow. Adios.